Alright, I'm back to teach you more about while loops and probably to cough a little bit on you. I apologize for that. I'm pretty sure my cough won't transfer over YouTube, so you should be okay. Anyway, uh, we were in the middle of learning about while loops, and that's when my computer ran out of disk space. And okay, but what I'd like to do now is take a look at the while loop we wrote in the last video and cough. Excuse me. The while loop we wrote in the last video said something like this. We were darkening a hallway, and it said, I believe while the front is clear, and I think we were in a file called lesson, maybe? We said ensure dark, and then move, and when we got to the end, I think we established the front was no longer clear, but we had one more time we needed to ensure dark. So that illustrates something that comes up often in while loops, which is that sometimes there'll be that one extra case that isn't handled inside the body of the loop that we need to have an extra bit of code that executes outside of the loop. In this case, because we have to ensure one more cell is dark than the number of times we move. And we discussed that in the last video, so I won't go into it again. Something I'd like to do, a nice little shortcut, is it turns out if the method call that we're making, like ensure dark, appears in the same file as the code that we're currently writing, which this code was, I believe, also in the lesson file, then it turns out we don't have to write lesson dot. And I will summarize that for a moment. But it turns out there's a nice shortcut in Java. If the method is declared in the same file that we're calling it from, then we do not need to specify the file name. It's implied that it's the same file that we're already in. And I think when I do these little examples, it's nice not to have to worry about which file it's in. We can just understand, oh, it's in the same file, whatever that file happens to be called, right? The fact that I called the file lesson.java shouldn't really matter to us as we're trying to understand this code outside of the context of that file. So the rule is, remember we have 4 kinds of statements so far: while loops, ifs, returns, and method calls. And let's take a closer look at those method calls. That's where we write something dot something and some parentheses, such as robot.frontIsClear or robot.move or lesson.ensureDark, where this first part is the file name and the second part is the method name. And what we're learning now is that this first part with the dot is optional if the method is declared in same file. Okay, so there's a nice little Java shortcut. I like to avoid Java shortcuts because I think it potentially overwhelms beginning programmers, but here's a really nice one. As long as every time we call a method, we still need to think to ourselves, what file is it in? Oh, it's in the same file, then we can leave it off. Oh, it's not in the same file, then we better write the file name. So don't get too comfortable with this shortcut, but it does make my examples a little bit cleaner to read. So let's continue on. I want to take a look at this code and see what is it we know at various points in the code. So how about right at this moment in the code, when we first enter the while loop, but before we've called ensure dark? Well, for one thing, we don't know whether or not the square is dark. Ensure dark will make sure it's dark afterward. But what do we know about what's in front of the robot? Is there a wall? No, there can't be a wall, because I only enter the loop if the front is clear. So I know the front is clear if I've entered the loop, and I have entered the loop if I'm asking about this moment right here. So I know the front is clear. Okay, what do I know at this moment here at the end of the loop? Right at the end of the loop before we go back to test again. Well, I don't know anything about the front. Don't know if front is clear. And I don't know that because it's possible the front is clear, in which case we'll loop again, and it's possible it's no longer clear because we moved, in which case the loop will exit. Which brings us to, what do we know right here after the loop has ended? Well, we know the front is not clear, because if the front were clear, the loop would not have ended and we'd still be going around. So when the loop exits, I know for sure that the loop condition is false, the front is no longer clear. Alright, so with that in mind, that might save us from some silly code. So let's look at some silly code. Here's some code that I wrote when I wasn't paying any attention and I wasn't thinking about excuse me, loops, maybe because I'm delirious and sick here. If, oops, front, nope, let's do this. Okay. Here's some code, and the dot 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 indicates that there's more code I'm not showing you. It's not important. I just want to focus on this little bit of code here. How do we feel about this code? How do we feel about this if right here? Well, that if is ridiculous, right? I know the robot's on dark because that's what this while loop says. If the robot is on dark, enter this loop. And if we've entered the loop, we know the robot's on dark. So this is silly because we know the robot is on dark. How about, see, I don't know if that's going off your screen, so we'll just do this. How about this if at the end? Well, that's also silly. That was ridiculous of me. Why would I do such a thing? But why is it silly? It's silly because if the robot were on dark, I would still be looping. So if we've exited the loop, the robot could not possibly be on dark because, because we know the robot cannot possibly be on dark. If the robot were on a dark square, we would still be in the loop. Okay, let's look at a few more interesting while loop examples, and then we'll get back to more practical examples. So here's one. How about, I don't know, while the robot is on dark, we will, where'd my cursor go? We will turn left. What does that code do? Think about that for a moment. While the robot's on dark, turn left. Well, it should strike you that there's two possibilities. If the robot is on light, then this code does nothing, right? If we're on light, we're not on dark, we don't enter the loop. Does nothing. Okay. If the robot is on dark, and I think that actually serves to remind us that just because we write a loop that something's going to happen repeatedly, it's possible it doesn't even happen the first time, right? If the loop condition is false at the beginning, we never enter the loop, the body of the loop does not execute even once. Now suppose the robot actually is on a dark square. Now what happens? Well, we're on dark, so the robot will turn left. And we test again. Is the robot still on dark? It has to be. All it's done is turned. So the robot is turned, we turn left, we turn left, we turn left. The robot keeps turning left, and it's perpetually on dark. So what does this code do? Well, if it's on light, it does nothing, and if it's on dark, turns left forever. So this is what's called an infinite loop. It's our first example of an infinite loop. And it's possible I don't know if we've written something else that could be an infinite loop, but we'll see lots of infinite loops. Sometimes it's a very useful idea. Maybe you want the robot to turn left forever, in which case actually this is kind of a silly way to do it. I'll show you a smarter way in a moment. So sometimes an infinite loop is deliberate, and sometimes it's because we mess up in our code and we don't have anything in the body of the loop that ensures that the loop condition will eventually be false. So if I did want to loop and turn left forever, here's how I could write that. While true, turn left. Right? Remember, the thing in these parentheses, let's go back and prove that I've already said this. Aha! The thing in the parentheses is a Boolean expression. And each time that Java is considering entering that loop, it evaluates that Boolean expression. And that Boolean expression might be something like robot on dark or not robot on dark or whatever, but it could just be true. True is a Boolean expression, and the value of true is true. It's always true. And because it's always true, this loop will always enter the loop. So this loop will cause the robot to turn left forever. Turn left forever. In every scenario, Java will always enter the loop and turn left forever. So this is another infinite loop. Let's look at one more example. Sure, we can keep that on the screen. One more example. While true, okay, so you know this is going to be an infinite loop, although I guess it's possible that we do something in here like return from a method, in which case now it's no longer an infinite loop, and we'll see that actually. But before I get there, excuse me, while true, you know what? Let's do nothing at all. While true, nothing. Do nothing. So this code says to do nothing forever. What does that mean, do nothing forever? Is Java going to get clever and say, wait a second, you're always doing nothing. I don't even have to run this code. Nah, Java's not that smart. Every time you tell Java something like this, Java enters the loop. Oh, true is true, so I'll do nothing. And then, oh, true is true, I'll do nothing. Oh, true is true, I'll do nothing. Right? The computer is just following your orders, and in this case, you've ordered the computer to do something pretty silly. And so, what's going to be the overall effect? It will look like your program has hung, has frozen, right? It will look like your computer froze. And it didn't really freeze, it's still working like crazy. It's exhausted testing if true is true and doing nothing. But from the outside, it's going to look like our program has frozen. So when we see that it looks like our program is stuck, when we're writing a program and it's stuck, one thing we're going to suspect is maybe we have an infinite loop, and that loop is not accomplishing anything, and that's why it appears our program is stuck. So that will happen to us many times. When it does, we'll suspect that we have an infinite loop that's not accomplishing anything. Alright, I'll see you in the next video when I think we'll take while loops to the next level and actually solve an interesting problem, depending on your definition of the word interesting. I'll see you there.